All right, so I wanted to help you with, what is this, problem 8? It's not problem 5, it's problem 8. There you go. So, let's see here. It's kind of a funny problem. A man pushes a 2-kilogram broom at a constant speed across the floor. Okay, and I'm also going to assume constant direction. Which makes situation constant velocity, which is 0 acceleration. It says the broom handle makes a 60-degree angle with the floor, so that's that angle there. He pushes the broom with a 5 Newton force. Okay, so I know that the applied force by the person, and I know the mass of the object. Okay, so the broom, I guess, is like this whole thing. That's my system, right? That's the whole thing. So the broom, there's weight, and there's got to be normal up, right? I'm thinking there's friction too. I'm thinking there's friction to the left. I don't know how big these things are, but I'm just going to guess. And then the person's pushing at an angle 60 degrees. But if I connect this, the 60 degrees is here on my force diagram, right? So that's what's tricky about this problem, is that angle is a little bit tricky. So the broom makes 60-degree angle with the floor, but the applied force, I'm going to call it capital F due to person, it's 60 degrees below the horizontal. Okay? So, and I guess I could make a reference line here that might help. And then I'm thinking that this is also 60 degrees. And that means this one is to be 30 degrees here, right? This is 30 degrees there. So I hope that helps us get a good start. Now, I'm going to assume, since constant velocity, that means that acceleration is 0. That means the forces all must add to 0 as vectors, right? This is essentially just n1 right here. All right? And now if I do the vector sum diagram, I have the applied force. I have normal, which is going to have to be quite long. And then I have friction, right? Applied force, normal, friction to the left, and then weight will be straight down. Now I'll label those vectors: weight, normal, applied force, I'll just call it capital F, and friction. And maybe I'll use the mass now to find the weight of the object. So the weight of the object is going to be mg. So that means the weight is going to be the mass of my system, which is 2.0 kilograms times 10 newtons per 1 kilogram. So for every kilogram, the Earth pulls with a force of about 10 newtons if you're on the Earth's surface. So kilograms divides into kilograms to make 1. That makes 20 newtons, the weight of the broom, right? So that means this vector here is 20 newtons in length, right? Maybe I'll add some reference lines now. Okay. Now, that means this is 60 right here. This is a right angle there. So the other angle really has to be a 30, and I can check it. Yes, it is a 30. So this angle is 60, this angle is 30, right? So he pushes the broom with 5 newtons of force. So that's, this force here is 5 newtons, that applied force F, right? And that's the long side of that of this triangle here, right? So that means the shortest side of that 30, 60, 90 right triangle has to be 2.5 newtons. That's this side here. Nope, that's not that side. Sorry, I'm wrong. It's this side. So from here across is 2.5 newtons because that side is opposite my smallest angle, right? So that means the friction has to be equal to 2.5 newtons. The weight is 20. The applied force is 5 newtons. The medium length side of my little right triangle right here has to be the shortest side, which is 2.5, radical 3 newtons. That's my medium length side. Sorry, not my shortest. My medium length side is 2.5 radical 3 newtons. So that means my normal force in total, since 20 newtons is from here to there, if I add 20 plus the 2.5 radical 3, my normal force is 22.5 times radical 3 newtons. And now I've found all the forces. I've found the magnitudes and the directions of all the forces acting. And that's the last problem. I hope these solutions help you out. Whatever you do, don't look at them first. Try the problem, and then when you get stuck, you can look at the solution, and it might help. Anyway, good luck. Have a good day.